Australian aircraft production had its humble beginnings in 1909. George Augustine Taylor, founder of the Aerial League of Australia and a proponent of Lawrence Hargraves's earlier experiments with box kites, set up a small facility at Surrey Hills in Sydney where he produced 2 gliders. Then, just after World War I, the Australian Aircraft and Engineering Company set up a factory at Sydney's Mascot to license-build Avro 504K biplanes, including 6 built for the RAAF in 1922 from Australian timber. These were the important beginnings of an Australian aircraft industry that will prove indispensable during the Second World War and beyond. This is the story of homemade wings. In 1930–31, the Larkin Aircraft Supply Company, known as Lasco, set up a factory and airfield at Coode Island in Melbourne and built 32 de Havilland Gypsy Moths for the RAAF. Lasco had previously designed and built the first Australian airliner, Australia's first metal aircraft, in 1929, a decade before the Wirraway. In 1933, it produced the first multi-engined airliner to be designed and built in the Southern Hemisphere. That period also saw General Aircraft Company, Gen Airco, produce a unique de Havilland Avro hybrid biplane at Mascot, New South Wales. Gen Airco was superseded in 1933 by Tugan, whose general manager was squadron leader Lawrence Wackett. He had headed the RAAF experimental aircraft section at Randwick in 1924–31 and designed the successful Wackett-Widgeon flying boat during his tenure. Resigning from the RAAF, Wackett worked at Cockatoo Island Naval Dockyard in Sydney to design a twin-engined airliner, the Codoc, for Charles Kingsford Smith. Returning to Tugan, he designed its successor, the Tugan-Wackett Gannet, 7 of which were built at Mascot, and in 1935 made history as the RAAF's first locally designed and built aircraft. Wackett, a strong advocate since the 1920s for a local industry, has been called the father of Australian aircraft manufacture. Its godfather then was perhaps Essington Lewis, general manager of BHP Iron and Steel Company. In 1935, Lewis returned home from a fact-finding tour of Europe, convinced of 2 things: war between Germany and Britain, and therefore Australia, was on the way, and Britain may not be able to supply Australia with all its aircraft requirements. He lobbied the Australian government to establish a modern aircraft industry. The following year, Wackett toured Europe, including Germany and America, as part of a mission to select an aircraft type that would be within Australia's capacity to produce. Wackett recommended the North American Aviation NA-16 and NA-33 training aircraft, forerunner of the famous T-6 Texan Harvard trainer. With the involvement of Essington Lewis of BHP and Lawrence Hartnett of General Motors Holden and of Broken Hill Associated Smelters and Imperial Chemical Industries, the Commonwealth Aircraft Corporation, or CAC, was formed as a private company in October 1936. General Motors Holden in particular, headquartered at Fisherman's Bend at Port Melbourne, gave the company the experience of its executives and production engineers in running factories and subcontracting. A manufacturing license was secured from North American Aviation, a major departure from the traditional choice of Britain as the source of all things aviation, and within a year, a factory and airfield had been completed at Fisherman's Bend. CAC acquired the Tugan Company's assets as its core, and with it, Wackett as managing director. CAC began production in a remarkably short time, setting to work on a modified version of the North American trainer. Named Wirraway, an Aboriginal word meaning challenge, it featured a new tail section and other refinements, including the ability to carry armament. Some component production was outsourced to various firms, such as Richards Industries in Adelaide, which produced Wirraway wings, and later parts for the Beaufort, Beaufighter and Lincoln. The Wirraway, its Pratt & Whitney engine, also licensed built by CAC, entered service just before the outbreak of war in 1939. It was not only the RAAF's new advanced trainer, but also a general-purpose aircraft capable of Army cooperation, dive bombing and air defense operations.
Day by day over England's embattled isle continues the heroic fight for freedom. Empire pilots hurl into the fray the fastest, fiercest warplanes in the world, whose breathtaking exploits have thrilled every nation, with the possible exception of the enemy. Australia also thrills with pride at the miraculous achievements of both men and machines. and Australia follows the lead of the homeland. For her defense, she now makes her own warplanes, and in a year creates one of the greatest aircraft factories in the world at Fisherman's Bend, Melbourne. Here on the tarmac, outside the Commonwealth Aircraft Corporation's factory, is an Australian-made Wirraway, a trainer, fighter, bomber designed by Australian experts, made by Australian workmen from Australian materials. And metal, fashioned from the ore that lies in the heart of Mother Earth, arrives in ingots at the factory, then into this glowing open hearth furnace. And now, as the furnace is tapped, you see the molten metal run out, a white-hot river into the waiting molds, then into the quenching water, steam rising and hissing in angry protest as tireless Australian workmen forge it into the nation's defense. Thus the molten metal is ladled into the molds, there to take its first semblance of the shape of things to come. All metal is tested before it leaves the manufacturer, and again at the factory before it's accepted. No chances are taken at Fisherman's Bend. And now, looking a little more businesslike as the bandsaw cuts the metal parts of a future Pratt & Whitney aero engine, the power behind the wings of the Wirraway. Parts that are polished into smoothness by hand, ready for machining in the only factory in the world in which the airframe and engine of an aeroplane are made in the same plant. Built on reclaimed land 2 years ago, this factory has become the cradle of the Royal Australian Air Force. Here, passing before you, are the parts of the Pratt & Whitney engine and the machine tools that make them. Milling machines, gear generators, and hobbing machines which cut through the tough steel for the gears. And there the angle spindle drill, boring valve stem holes in a cylinder head. Now a trolley load of completed heads ready to be given a final finish by hand. Australian workmen's hands, as deftly and efficiently doing their job as the men who will soon race through the air in the planes they've made. Each finger's touch in this factory as sure as the pressure that will later hose a stream of lead into the Nazi enemy. There are many kinds of grinders used, but this is a Churchill grinder, here seen grinding a crankshaft, and a pretty good grinder of cranks it is. Although modern machine tools are almost uncanny in their accuracy, some finishing operations must still be done by skillful hands. The master rod, lifeline of an engine. The rod that carries 8 other connecting rods is here being checked by a micrometer with the standard gauge. Any error is as bad as a mile out, when there's nothing between the pilot and death but the master rod of his engine. Then a boiling oil bath for the master rod and an ice pack for the main bearing sleeve. Dry ice is used to contract the sleeve, which is then slipped into the hot master rod. The sleeve expanding as the chill wears off, and the rod contracting as it cools, ensuring an absolute tight fit. Now the other 8 connecting rods are attached to the master, just like a huge starfish. The broaching machine performs the important task of cutting the splines that loose couple the crankshaft to the propeller boss. Looking somewhat like a Swiss cheese is the crankcase, subject of many kinds of drilling, boring and facing operations. And here are crankcase ends with their intricate gas passages. The main assembly table, on which is a complete set of parts, numbering some thousands, used in the construction of a Pratt & Whitney single-row aero engine. These are ready for assembly. The highest possible standard is set in this factory to ensure that only the best methods and materials go into the making of a Wirraway, so that our pilots never need fear of being let down by their aircraft. But it's simple everyday work to these Australians. Every man is a specialist in this war of specialists, at home and abroad, on the ground and in the air. Each expert is adding one little bit more to the great victory effort. The actual assembly seen here is a careful, painstaking job and needs a high degree of technical skill. Careless assembly can ruin an engine even before it feels the air. This engine, rapidly nearing completion on a convenient rotating table, will soon be ready for its stringent tests. Now assembled, ready for duty, here are rows of completed motors. Aeroplane engines made in Australia. Now think what that means. Think back a couple of years when it sounded a dream. But today, Australia is making her own engines for her own planes, making them before she has made motorcar engines, conquering the air before the roads in the urgent hour of the Empire's destiny. That's war for you. And here is Australia's Wirraway assembly plant, kernel of our defense, something to make Hitler grunt in his mountain lair. Finished engines, frames, wings for Australia's Wirraways, rods, tubes, structural parts of all descriptions. Australia's answer to the challenge to freedom is being forged by Australian workmen, moulded and patterned here at Fisherman's Bend.
By 1946, a total of 755 Wirraways had been produced. 3 other CAC aircraft followed the Wirraway into production before war's end. The Wacket trainer, intended for intermediate pilot training to follow on from Tiger Moths, was the company's first wholly locally designed aircraft and the RAAF second after the Wacket Gannet. The next was the Boomerang, adapted from the Wirraway by Friedrich David in just a few months. Using 65% Wirraway parts, the Boomerang was an emergency fighter, designed with the expectation that imported fighters would not be arriving for some time. Though inferior to Japanese fighters, it nevertheless had good maneuverability, out-turning and out-climbing the Kitty Hawk and Aerocobra, and cannon armament. In the end, it was not needed for air defence, as imported Kitty Hawks and Spitfires fulfilled that role. The Boomerang, instead, served in the Army cooperation and reconnaissance roles in New Guinea. CAC also licence-built and overhauled US Pratt & Whitney aero engines at Lidcombe in Sydney. The single-row Wasp radial engine powered its Wirraways, while the twin Wasp powered its Boomerangs, as well as the Department of Aircraft Production Beaufort bombers. In late 1942, the government started looking for a replacement for its Kitty Hawk fighters, and the following January, Secretary McVeigh of the Department of Aircraft Production led an overseas mission, which included Lawrence Wacket, to evaluate the options. After assessing the Spitfire, Thunderbolt and Mustang, the latter was chosen as the best all-round fighter and the least problematic to build. McVeigh's mission recommended CAC build Mustangs, thus continuing its relationship with North American aviation. Production got underway in 1945, slightly too late for CAC Mustangs to see war service, and ran for 6 years to supplement some 300 US-built Mustangs previously supplied. A few CAC-built Mustangs saw action in the Korean War alongside their US-built counterparts. Before joining the Air Force in 1948, Keith Meggs worked at the CAC factory as flight crew, who made sure the finished aircraft was running correctly.
2 years there I was approved to start up Mustangs, their first engine run, right through to the time they were given their final test flight and flown off. And I became the armourer there too. Well, when Mustangs were first stowed down there from the factory, they had to be prepared for the first engine run. And the first engine run entailed checking the tappets on the top of the engine, of course. You know what tappets are? I think they work the push rods on each cylinder. So you had to check that. You had to check carburetor settings. And they were given an initial run, just a short run, to make sure there were no oil leaks or coolant leaks. After, of course, you check the oil level and the coolant level. And coolant, of course, in a liquid-cooled engine is the same as the radiator in a car. It has to be full. So after the first run, which was only a short one, with all the cowls off and the spinner off the propeller, everything was gone over to make sure there was no leaks. Then the cowls were put on, was given another run up to, on the ground, 61 inches of manifold pressure. And you couldn't run a Mustang up to above 40 inches, and that's opening the throttle. With 40 inches or more, the tail would lift and it's likely to hit the propeller on the ground. So for any runs above that, it had to be tied down with about 800 weight of concrete blocks through a big bar through the back of the fuselage. Then you could run it up to 61 inches. But in setting of that 61 inches, sometimes the throttle would be such you might go to 63 or 64 inches. In fact, 67 was an emergency setting that the pilot could go to, so you did have to go to that to make sure it was going to 67. But the settings were done, so the throttle was adjusted so that in normal flying and for takeoff, 61 inches was the maximum you were allowed. So that setting was done. Then you go through the throttle, through the gate, and make sure you had 67 for emergencies. But there was wire put across that, copper wire. So if ever it went through that gate, the ground staff, the engineers, would have known that, and the engine would have had to be inspected very carefully to make sure it hadn't burst anything. The workmanship in the Australian Mustangs was superior to the American, because most of them were built after the war. We'd only started supplying the Air Force in late 45 with our own, and as the war ended, they were built on a much slower basis, and the standard of workmanship was much higher. And that was quite apparent when we flew American Mustangs. They were built under the war pressure with the idea that they probably weren't going to last long anyway, and the workmanship wasn't such a high standard.
Two other CAC designs of note, though built only as prototypes, were the Woomera and CA-15. Both were interesting designs but were not needed. The Woomera was a stopgap light torpedo bomber designed in case of supply hold-ups of imported types. The one-off CA-15 was a Fred David design of 1943, with plenty of power up front, courtesy of a Rolls-Royce Griffin V12 engine. Despite its 720 km per hour, or 390 knots level flight speed, the CA-15 was considered deficient, as piston engine fighters were rapidly becoming obsolete by 1946 when it first flew. The jet age killed off the CA-15, and CAC entered that age with another North American aviation design, the Sabre. Contracts were signed in 1951, not long after the type had first appeared in action in US service over the Korean Peninsula. CAC improved on the US design by using the more powerful, locally built Rolls-Royce Avon jet engine, replacing the machine gun armament with a pair of 30mm Aden cannons and increasing its ordnance and fuel capacity. The first Avon Sabre flew in 1953 and replaced the Meteor and Vampire as the RAAF's fighter for a decade, until it was replaced by the Mirage 3.0. From 1945, CAC became rather adept at building engines and will build more than 100 Rolls-Royce Merlin V12 engines for its Mustangs and for the Australian Government Aircraft Factory, GAF, Lincoln bomber. In the 1950s, CAC built Rolls-Royce jet engines, Avons for the Sabre and GAF Canberra bomber, Neens for the de Havilland Vampire, and Vipers for the Macchi Trainer. In the 1960s, they built the ATAR engine designed by the Société Nationale d'Études et de Construction de Moteurs d'Aviation, otherwise known as SNECMA, as well as wings and tail fin assemblies for the GAF Mirage. In the 1980s, they built General Electric F404 engines for the FA-18 Hornet. The CAC-designed Winjeel replaced the Tiger Moth and Wirraway as the RAAF's trainer in 1955. The next big CAC project was the Italian-designed Air Macchi, more commonly known as the Macchi, the MB-326H jet, which flew in 1967. The Macchi was originally intended to replace both Vampire jet and Winjeel piston engine trainers, but it was decided the jets were too advanced for elementary training. The New Zealand-built piston engine CT-4 instead replaced the Winjeel, while the Macchi saw service both as a lead-in fighter trainer and with the Roulette's aerobatic team, until replaced by the Pilatus PC-9 turboprop trainer. In the 1980s, CAC became Hawker de Havilland Victoria, which later became a subsidiary of Boeing Australia. The second Australian company to supply wartime aircraft to the RAAF was the Australian subsidiary of Britain's de Havilland Aircraft Company, or DHA. After moving from Melbourne to Sydney's Mascot Airfield in 1939, DHA began production of more than 1,000 Tiger Moth training biplanes, while the GMH factory at Pagewood near Mascot built their Gypsy Major engines. The Tiger Moth supplied the Empire Air Training Scheme, not only for the RAAF, but supplemented supplies for the other British Dominion nations as well. A monoplane de Havilland trainer, the Moth Miner, also joined the production line, and de Havilland also produced propellers for the wider Australian aircraft industry. The combination of a new DHA assembly plant at Bankstown and the availability of Sydney factories and workshops such as GMH at Pagewood and the Beale Piano Factory at Annandale led to production of wooden Mosquito fighter bombers and photo reconnaissance aircraft in 1943. DHA and GMH underestimated the complexities of the aircraft's laminated timber construction and quality control, and several Mosquito aircraft suffered catastrophic in-flight structural failure of the wings built at Pagewood. That was one reason for its very low production rate, which did, however, keep the Bankstown DHA factory operating until 1948, when production turned to the RAAF's first operational jet, the composite wood and metal Vampire. Vampires were built in interceptor, fighter bomber, and two-seat trainer variants. In 1965, DHA became Hawker de Havilland, following a merger with Hawker Siddeley, and its aviation division became Hawker Pacific in 1980. During 1987 to 1991, it assembled Sikorsky Black Hawk helicopters, initially for the RAAF, and then for the Army when it took over rotary wing assets. CAC's Pratt & Whitney Twin Wasp engine powered not only its Boomerang, but also the RAAF's primary wartime general reconnaissance bomber aircraft, the British twin-engined Bristol Beaufort. In March 1939, a British air mission visited Australia, and perturbed that CAC had chosen an American design for its first product, decided that British interests should prevail by recommending that Australia, though not CAC, assemble Beauforts to supply both the RAAF and the Royal Air Force. The production of 700 Beauforts, each assembled from 40,000 parts at a peak rate of 1 per day, was a prodigious undertaking for Australia's small industry at the time. It is all the more remarkable considering that material and support from Britain stopped in mid-1940 before production began. 7 factories were commandeered or built, including the GMH automobile factory at Woodville, South Australia, and state government railway workshops in Victoria, New South Wales and South Australia. Some 600 subcontractors were engaged. To coordinate it all, and to provide the centralised assembly plants and staff, a new government department and division was created, the Department of Aircraft Production, or DAP, headed by industrial dictator and soon-to-be Director General of Munitions, Essington Lewis. DAP's Beaufort division was headed by GMH Director John Story, and factories were soon built at Fisherman's Bend, next to CAC, and at Mascot. Thus, with the beginnings of an aircraft industry at the start of the war, Australia was in good stead in case supplies from Britain, which was suffering its own precarious war constraints, ran out. But the RAAF could not rely entirely on local production. Aircraft supplies were supplemented by large deliveries of US and British aircraft, the latter initially for the Empire Air Training Scheme, Tiger Moths, Ansons, Oxfords, Battles, but from 1942, combat types including Spitfires. 46 Beauforts were converted to Beau freighter transports, and the next aircraft on the DAP production line in 1944 was the Beaufort strike fighter development, the Bristol Beaufighter. While British-built Beaufighters had served in the RAAF since 1942, Australia was now building its own version of the most formidable ground attack aircraft available in the war against Japan. Official historian D.P. Mellor wrote that aircraft production was one of the great achievements of Australian industry. Through the war years, CAC, DHA and DAP between them built some 3,500 aircraft of 12 types, and CAC nearly 3,000 engines of 3 types. The McVeigh Overseas Mission of January 1943 had recommended that Avro Lancaster heavy bombers be built in Australia. During 1944 to 45, a DAP team spent some months at the Avro factory at Manchester in England, becoming acquainted with the Lancaster Mark IV, which was soon renamed Lincoln, as it was largely a new aircraft. Although the war had been over for a year when the first fully Australian-made Lincoln was completed, and the RAAF had been drastically downsized, in the emerging Cold War climate, the RAAF kept its order in place. Replacing the US-built Liberator in RAAF service, the Lincoln bomber was the largest and most complex aircraft yet built in Australia. Its replacement, the English electric Canberra twin-jet bomber, was chosen by a delegation to Britain headed by the Chief of Air Staff, Air Marshal George Jones. Canberras began coming off the production line at GAF's new factory at Aviation, Melbourne, in 1953. Subcontractors were used extensively. The Canberra was a quantum leap in RAAF strike capability and performance. In fact, a production aircraft's delivery flight to Australia from England in 1952 set speed and altitude records for the route. The Mark 20 version built by GAF was based on the British-built Canberra B2, but included refinements such as a reduction in crew from 3 to 2 and integral wing fuel tanks. Also in 1952, a radical GAF product, the Jindovic, first flew. It was a pilotless, radio-controlled drone used to provide a representative target for guided missile tactical training and development. Apart from the RAAF and RAN Fleet Air Arm, Britain was a primary customer, and a number were supplied to both the USA and Sweden.
Design and engineering staffs at the Government Aircraft Factory near Melbourne have designed and built one of the world's best pilotless target aircraft, the Jindavic. A Swedish mission recently in Australia described this as the finest target aircraft in the world today. And Sweden has bought a number of Jindavics which have now been exported to the Royal Swedish Air Force. This is the Australian aircraft industry's first big export order, and we're proud of it.
In terms of numbers produced and longevity on the production line, spanning over 40 years, the Jindavic was one of GAF's most successful products. As a replacement for the Sabre fighter, in the early 1960s, Australia initially considered the American F-104, but instead turned to France for its next fighter platform, the Mach 2-capable Dassault Mirage 3. The Australian version, designated Mirage 3.0, differed in detail from the Mirage 3E and was produced by GAF at Fisherman's Bend. Wings, tail fin and engines were made by CAC, and final assembly and test flying was completed at Havilland near Geelong. The first 15 aircraft included imported French components. 50 of these Mirages were built as interceptors, 50 as ground attack aircraft, and 16 as Mirage 3D two-seat trainers using imported fuselages. The GAF Nomad utility aircraft, powered by twin turboprop engines, has been one of the most controversial Australian-designed aircraft due to serious concerns with its structural integrity and flight characteristics. Of the 172 built, most saw civil or army use in Australia, the Pacific and North America, while only 5 saw RAAF service over 20 years from 1977. The US firm McDonnell Douglas provided the design for the next GAF product, the twin-engined, twin-tailed FA-18 Hornet, which was chosen in 1981 over the single-engined General Dynamics F-16 fighter. The RAAF ordered 75 Hornets, including FA-18B two-seat trainers. Again, the engines were license-built by CAC. The first classic Hornet was delivered in 1984, and the last example was delivered to RAAF base Williamtown in 1990 by test pilot Ron Haack.
I graduated from the Empire Test Pilot School in 1978, and I got involved in project work and test flying almost for the rest of my life so far. Probably the highlight of that exercise was flying F-18s out of government aircraft factories as they came off the assembly line. I was sent down there as the McDonnell Douglas representative and did most of the first flights, or a lot of the first flights in the aeroplane. That was always very exciting. As you can imagine, jumping in a new aeroplane is a bit like jumping in a new car. It's got that nice smell about it, and it's all very clean and pretty. The actual test flying was pretty straightforward. It really wasn't testing as such. It was more just functional qualification or evaluation. The first thing I can say about the Hornet is it was a carefree aeroplane. Coming from the Mirage, which was quite a challenge to fly, largely because it didn't have a decent communication system. It had very little fuel, and it was very, very, not unstable, but it was quite a handful to fly accurately and precisely. Whereas the Hornet was quite a stable aeroplane. Obviously, fly-by-wire, artificial feel, all that sort of stuff. And it had lots of fuel, had good communications, and a very comfy cockpit. So you felt really, really very comfortable in it after a couple of hours. And so it was just a delight to fly. So initially, when I got back to Aviation after my training in the US, I was working with government aircraft factories. And about a year and a half later, I believe it was, the government decided to sell GAF and turn it into a commercial entity. So it became ASTA. The previous chief test pilot at GAF, Government Aircraft Factories, retired. So I was then appointed as the chief test pilot for ASTA. In that role, I was doing the Hornet flying. I was also flying at that stage. I was still doing deeper maintenance on Mirages down Aviation. So I was flying the Mirage, and we're still working with Nomads, so I was flying Nomads as well. So it's quite an interesting time to fly those different varieties of aeroplanes.
In 1987, GAF was corporatized and renamed Aerospace Technologies of Australia, or ASTA, before being bought by Rockwell, now Boeing Australia. The Australian government's long involvement with military aircraft production thus came to an end. ASTA's first new production was the Pilatus PC-9, a turboprop-powered advanced trainer from the same Swiss company which had provided the Porter for the Army during and after the Vietnam War. As was the case with the Mirage, CAC built the PC-9's wings. In 1997, Britain's BAE Hawk lead-in fighter trainer was the next aircraft chosen for RAAF production. The majority, 21 examples, were assembled from imported and Hawker de Havilland Victoria manufactured components at RAAF Williamtown near Newcastle, New South Wales, while their jet engines were assembled by Qantas Defence Services. Since the Hawk, and until the recent MQ-28A Ghostbat development, Australian aircraft industry had turned more to component and systems manufacture and conversion work than entire aircraft design and development. At Amberley near Brisbane, 4 Boeing 737 airliners were converted to wedge-tail airborne early warning and control aircraft, while Qantas Defence Services at Brisbane converted 4 Airbus A330 airliners to RAAF KC-30A multi-role tanker transport aircraft. Some 17 Australian companies produce electronic and airframe components for the growing global F-35 Lightning II fleet. I'm sure the timber and fabric workers who built the half-dozen Avro biplanes for the RAAF at Mascot 100 years ago would be proud of the Australian industry they started.